Today is Saturday, so we're having
A Saturday quiz, yay!
Yes, today's quiz is going to be on science. So get yourself set. Here we go. Shalom. What causes disease and what does the body do about it?
Diseases are caused by pathogens. I'll name two: bacteria and viruses. These pathogens come into your body through contact with someone who's ill, cuts in the skin, and food poisoning. Your body has defenses to destroy these bacteria before they can come into your body, and that is the skin, tears, stomach acid, and the immune system. When your body is under siege, the immune system sends out white blood cells to destroy the bacteria or viruses. The white blood cells has three choices. They can either engulf the bacteria or virus and neutralize it, send out antibodies to stick on the bacteria or virus and destroy them, or shoot out antitoxins which will neutralize the toxins sent out from bacteria.
Okay, yeah, that's good. Can you give an example of bacteria and viruses, please?
An example of a bacteria is syphilis and gonorrhea, which is an STI, and also leprosy and leprosy
TB.
and TB. Yeah.
Viruses?
Examples of viruses are flu and chickenpox.
Okay, that's good, that's good. So how can we artificially protect the body from present and future diseases?
Scientists and doctors have made things called vaccines and antibiotics. Vaccines are contain dead or weakened bacteria or the pathogen.
Okay.
That is injected into your body, and your immune system recognizes this threat and sends out white blood cells and destroys the culprit, and then your body remembers how to destroy that disease. So then, in the future, you won't get that disease.
Okay, that is good.
And and antibiotics are used to kill the bacterial virus then and then when you have got that disease. So it is for present uses.
Okay. The vaccines are for future uses.
Yes.
That is good. Can bacteria become resistant and what are their effects?
Yes, bacteria can become resistant. Bacteria are, like all things, mutate. And when the usage of a certain antibiotic is too much, they may mutate a trait through natural selection that makes them resistant to that antibiotic. Now, that bacterium that is resistant to that antibiotic will not die, but all the other bacterium that are not resistant to that antibiotic will die out, and the resistant bacterium will replicate.
I mean, they'll multiply and reproduce. Okay. Can you give an example of such a strain?
An example of such a strain is MRSA.
Okay.
It is very hard to control, and it is very it's put in it's very hard to control.
Okay. So the scientist needs to constantly come up with new antibiotics, isn't it? Okay. That was very good. Very good. Chantel, what is the solar system and what does it entail?
The solar system contains of the sun and all other objects revolving around it, such as planets, asteroids, comets, meteoroids, and moons. There are 4 inner planets, such as Mercury, Venus, Earth, and Mars. They are made of rocks and metal. There are 4 outer planets, which are Jupiter, Saturn, Uranus, and Neptune. They are made of gas. There are 5 dwarf planets, which are Eris, Pluto, Ceres, Makemake, and Haumea. The sun. The sun is a star. It is the biggest object in our solar system. It makes more than 99% of the mass in our solar system. It is what keeps the Earth and all other planets revolving around it, instead of drifting out into space. It is a big ball of gas made of 75% hydrogen gas and 25% helium gas. It is at the center of the solar system.
Okay.
Mercury. Mercury is the smallest planet in our solar system. Has a rocky surface with craters on it. It only takes 88 days to revolve around the sun. There is no air or water on the surface of Mercury. Mercury is extremely hot during the day and freezing cold during the night. Venus. It has barely the same size and gravity as the Earth, but has a very different surface. It is the hottest planet in our solar system, although it's not as close to the sun as Mercury. Its thick atmosphere of carbon dioxide traps heat and stays warmer. Because it is covered with clouds which reflects maximum sunlight, making it the brightest planet of them all.
How does it revolve?
Huh?
How does it revolve, Venus?
Because all the planets move anti-clockwise, but Venus moves backwards, which is clockwise, and Venus is also called the morning and evening star, because you can see it morning and evening. Earth is the only planet with living things on it. 70% of its surface is covered with water. It scatters sunlight and creates a blow effect. It only takes 365 days to revolve around the sun.
Yes, so every year, does it take 365? Was there?
After every 4 years, on the 4th year, the Earth is added one day on February the 29th.
Okay.
That's quite a leap year. The Earth has one moon, which is known as the Earth satellite. Mars. Mars is known as the red planet because iron oxide gives it its reddish colour. Its size and gravity is half the Earth's. Mars has the largest volcanoes and the deepest valleys in our solar system. Mars is similar to Earth as they both experience 4 seasons and they have a polar ice caps in the north and south poles. There's a ton of ice. Jupiter. Jupiter is the biggest planet in our solar system. Because it is covered with gas, there's no land to land on it. It is so huge you could fit 11 Earths in it. It is so big that you can fit all the planets on it. It is a very fast planet that it only takes 10 hours to rotate around its axis, while the Earth takes 24 hours to rotate around its axis. Venus is also called the vacuum cleaner of the solar system as it sucks comets, asteroids and dust into its surface, as its gravity surface is very high. Saturn. Another gas giant, it is famous for its beautiful 6 rings made of ice, rocks and dust. It is the second largest planet in our solar system. Uranus. Unlike other planets, it is tilted so much that it spins sideways. It is a very cold planet and it is made of methane. Neptune. Neptune is also made of methane, making it also blue. It's got 14 moons circling around it. It got the strongest winds in our solar system. Pluto.
Sorry, how many years does it take to rotate around the sun?
160.
Yeah.
160.
165.
Pluto. In 2006, after being listed as a planet for 76 years, it was declared a dwarf planet. There are at least 5 dwarf planets in our solar system.
So why was Pluto declared a dwarf planet?
Pluto was declared a dwarf planet because it can't clear its neighbourhood around it as its gravity is very low.
Oh, well done. That was very, very good. Shalom. Can you explain the Miller-Urey experiment?
The Miller-Urey experiment was an experiment conducted by a university professor called Miller and his student Urey.
Okay.
In this experiment, they tried to simulate early Earth conditions.
Sorry, did you say which year was that?
It was in the 1960s.
No, sorry?
1950s and 60s.
1952, okay.
Yes. In this experiment, they wanted to simulate early Earth conditions by conducting an apparatus that contained methane, ammonia, hydrogen, and water. The water was used to show the early Earth's vast oceans. They also used electric sparks that were passed along the mixture to simulate lightning. After a week of this experiment, Miller and Urey found out that they had created more than 20 different amino acids. This is amazing because you need a minimum of 20 amino acids to create a protein, the basis of life.
Okay, so the experiment was heralded as supporting the idea that complex chemicals can be naturally produced.
Yes.
Do we have any critics of the experiment?
Yes. Many scientists have criticized the Miller-Urey experiment on different grounds. The first flaw of the Miller-Urey experiment was that they had too much control. In this experiment, they had strategically positioned traps to get rid of poisonous gases. This is not naturally occurring. The second flaw with the Miller-Urey experiment was that it produced lots of poisonous gases. It produced 85% tar, 13 carboxylic acid,
Carboxylic
acid, and 2% amino acids. In the real world, the amino acids would have got destroyed by the poisonous gases. The first critique of the Miller-Urey experiment was that oxygen was not present. For life to evolve, oxygen needs to be present, but when oxygen is in the presence of life, everything oxidizes. So we have a chicken and egg problem. What came first?
So life cannot evolve with or without oxygen.
Yes. The fourth point of the Miller-Urey experiment was that it created right-handed amino acids. For life to exist, all the amino acids need to be left-handed. But the right-handed amino acids are not only useless, but toxic to life.
Good, well done, well done. That was very, very good. Chantel, can you explain the Newton's 3 laws of motion?
Newton's first law of motion states that an object will stay at rest or uniform motion unless acted upon by an unbalanced force. The second law states...
What is it called?
It's called the law of inertia.
Okay, so things want to keep doing what they're already doing, isn't it? Okay.
The second law states acceleration of the object depends on the mass of the object and the force applied. So force is equal to mass times acceleration.
Okay, so the bigger the mass, the greater the force needed to accelerate that object.
The third law states for every action there's an equal and opposite reaction.
Well done. That was good. Shalom. Describe the processes that take place in the carbon cycle.
The carbon cycle is the cycle in which carbon gets moved around in the atmosphere. Carbon first enters this cycle in photosynthesis and leaves in respiration. Plants and algae use photosynthesis to create food. The carbon is used to make carbohydrates, fats, and proteins. When this is done, some of the carbon gets released back into the atmosphere. Plants and algae also get eaten by animals, and these animals get eaten by other animals. The carbon that was in the plants gets transferred through the animals and is used in their cells. When plants and animals die, the carbon that was in them their remains get decomposed by microorganisms, and these microorganisms respirate, so the carbon gets released back into the atmosphere. Further, humans are the biggest contributors to carbon release. When we burn fossil fuels, it releases huge quantities of carbon into the atmosphere.
Okay, good. That was very good. Chantal, your last question. What is the cardiovascular system?
The cardiovascular system contains of the heart, the blood, and the blood vessels. The blood moves food, water, oxygen, and waste products around the body. It goes around the body through blood vessels such as arteries, veins, and capillaries. Arteries carry oxygen-rich blood from the heart to the body. Veins carry oxygen-poor blood from the body to the heart. Capillaries are tiny blood vessels that pass blood from arteries to veins. The heart is the size of your fist, located in the left-hand side of your chest. It is protected by the rib cage. The heart beats 100,000 times in a day. When the heart beats, it pulls blood towards it and pushes blood away from it again. The heart has 4 chambers. The chambers on the top are the left and right atrium, and the ones on the bottom are the left and right ventricle. Oxygen-rich blood goes from the lungs to the left atrium. It then goes to the rest of the body through the left ventricle. Oxygen-poor blood is pumped to the right atrium. It then goes to the right ventricle to go to the lungs that get oxygenated again.
Well done. That was very, very good. Thank you for watching. For more Saturday Quiz, please follow them on Facebook. Their page is called
Gravity is a sure thing.
Thank you.